Okay, today's video is lesson 3.5. This will be covering exponents with division. So our goal today will be to use the quotient rule, which is just another word for division of exponents, to simplify expressions. The quotient rule is when same bases are being divided, you can subtract the exponents. So if you can recall what we did in the previous lesson with the product rule, when same bases were being multiplied, we added the exponents. When same bases are being divided, like in our two examples here, we're going to do the opposite, and we're going to subtract the exponents. So we've got 5 to the third power being divided by 5 to the second power. We can rewrite this as 5 to the third minus the second, and we know that 3 minus 2 is 1, and we know that anything to the 1 power doesn't need the exponent shown. So we've got just 5. The abstract version of this is the same, a to the m divided by a to the n. We've got same bases. We can go ahead and subtract the exponents. So let's get into number 1 for the first example today. And as we go through this example, I'll identify the step for you. So the first step here is to identify the bases, and I'm going to go ahead and underline because it's easy for me to identify with my underline. So I've got the base x here, and I've got the base x here. So I've only got one base. The second step will be to identify the higher exponent. So now I'm going to look at the same base, and I'm going to identify what the higher exponent is. So I've got an exponent of 2 and an exponent of 3. 3 is a higher exponent, so I'm going to go ahead and circle that exponent. Now the third step is to write this expression with subtraction in the location of the higher exponent. So the location of the higher exponent right now is in the denominator. So I can rewrite this as 4 over negative x 3 minus 2. And you're probably wondering why this third step, why we're writing it in the denominator, not the numerator. And essentially what we're doing when we write it in the location of the higher exponent is we're saving ourselves a step because we won't have to convert a negative exponent. And I'll show you what I mean. So we could write this in the numerator. We could write, okay, 4x to the second minus the third over a negative 1. On our left side, when we simplify, we get 4 over a negative 3 minus 2 is just an x, 1x. We don't need to write the 1. And on our right side, what we get when we simplify this way, we get 4x to the negative 1, because 2 minus 3 is a negative 1 over a negative 1. Now you're saying, oh, okay, now I see why, because now we've got a negative exponent that we've got to convert to a positive exponent by flipping it over the fraction line. So we're essentially saving a step when we follow this third step and we write it in the location of the higher exponent. Now our last step here is step 4, which is to simplify the constants. So I've got 4 divided by, and this negative is essentially a negative 1. So 4 divided by negative 1, I'm just going to go ahead and move the negative into the numerator. So I've got negative 4 over x. So go ahead and make yourself a note if you have to. All negatives So you've got a negative in the end and it's in the denominator, you just got to move it up into the numerator. So our computer answer here will be negative 4 slash x. Example number 2. I'm going to identify the number of bases. I've got a base of x and I've got a base of y. Here's my x, here's my y. Step number 2 is to identify the higher of the two. 4 is higher than 2. And 5 is higher than 3. So now I can rewrite it for step 3 in the location of the higher exponent. So on my x base, it's in the numerator, so I've got 4 minus 2. And for my y base, it's in the denominator, so I've got 5 minus 3. I can simplify this to 2 over x, 4 minus 2 is squared, and 5 minus 3 is also squared. Now my fourth step is to simplify the constants. So I've got 2 divided by 3. 3 does not go into 2 evenly, so I'm just going to leave it as a fraction. I can't simplify this fraction because there's no common factor. So when I type this into Schoology, my computer answer is 2x to the second. And I don't have any room here, do I? My Schoology answer is 2x to the second over 3y to the second. Example number 3. We've got a, we've got a base of b, we've got a base of c. 5 is greater than 4, so I'm going to circle the 5. 2 is greater than 0, I'm going to circle 2. And then there's no number here, we know the number is 1. 4 is greater than 1, so I'm going to circle the 4. Now I can rewrite this in terms of my subtraction. So 2, c is 4 minus 1, sorry, over negative 4. A is 5 minus 4, and B was 2 minus 0. I simplify my subtraction, so 4 minus 1 is 3, and 5 minus 4 is 1. I don't need to write the 1, and 2 minus 0 is 2. Now my final step is to simplify my constants. So 2 divided by 4, 4 does not go into 2. However, this is a fraction that I can simplify. I can simplify the fraction 2/4 to find a number that I can divide both of these numbers by. So I can divide 2 by 2 and I can divide 4 by 2. So when I divide 2 by 2, I get a 1. When I divide 4 by 2, I get a 2. So I've simplified 2/4 to 1/2. And now I can go ahead and write this in Schoology. I've got to move the negative to the front. So my Schoology answer here is c to the third power, I don't need to write 1, over, I forgot to write the negative, so negative c, sorry, over 2ab to the second power. Two more examples. We've got m, we've got p, we've got n. N, p, and m. So sometimes they're not going to be lined up right on top of each other, so it's very important that you pay attention to that. We've got 2 and 2. These are the same number, so I get to choose where to keep it. I'm going to keep it in the numerator. 5 and 6, 6 is larger. 7 and 4, 7 is larger. So I can rewrite this as 6m 2 minus 2 and n 7 minus 4 over negative 3, 6 minus 5. I can simplify my subtraction. m 2 minus 2 is 0. n 7 minus 3 is 3. 7 minus 4, sorry. Over negative 3. p 6 minus 5 is 1. Now, anything to the 0 power, go ahead and make another note if you don't remember this. Anything to the 0 power equals 1 except 0. So we've got m to the 0 power, so m to the 0 power in this case equals 1. So we can go ahead and replace this with a 1. We've got 6 times m to the 0 power, which is just 1, times n to the third power, sorry, over negative 3p. 6 times 1 is just 6, so I can go ahead and just not write the times 1. So that's essentially what happens when you've got a variable to the 0 power. It's being multiplied as a 1, and that's not going to change the constants that you're multiplying it to. So you can pretty much just evaporate it. Now I can simplify my constants. I've got 6 divided by negative 3. 6 divided by negative 3 is a negative 2. N to the third over p. Last example today. We've got y, we've got x, and z. Z, x, and y. Let's see, 5 and 3, 5's larger. 3 and 4, 4's larger. 5 and 3, 5's larger. So we've got negative 7. Y, 5 minus 3 over negative 3. Z was 5 minus 3. And x was 4 minus 3. We can simplify our subtraction to y squared over z squared x. Now we can go ahead and simplify our constants. So we've got negative 7 divided by negative 3. Well, 3 does not go into 7 evenly, so I'm going to leave it as a fraction because there's no number I can simplify the fraction by. However, I can simplify the negatives. I've got a negative divided by a negative, which is a positive. So I've got 7y squared over 3z squared x. And now I'm going to put this into Schoology. And I always make sure to put it in A, B, C order. So we haven't had an example like that yet. So we have 7y squared over 3, x comes before z in the alphabet, z squared. Good luck on the homework.